Hi there. Today I will be solving all the questions from the first term general examination. My goal is to help those of you preparing for the second term to improve your chances of getting high mark. So let's start with the first question. The first question is from chapter 1 and says, a car tire rotates at an initial angular speed of 21.5 rad per second. The driver accelerates, and after 6.5 seconds, the tire's angular speed is 28 rad per second. So what is the tire's average angular acceleration during this period of time? So we already know that in this question, average angular acceleration, which is alpha, is unknown, okay? That's unknown. But we have initial angular speed, which is 21.5 rad per second. And then we have delta t, which is 6.5 second. And the tire's angular speed reached 28 rad per second. So that's omega final, which is 28 rad per second, okay? So since we don't have angular displacement in this question, we can use the first rule when the angular acceleration is uniform or constant to solve this question. So omega final is omega initial plus alpha delta t. Okay, so from this question, or from this rule, alpha is equal to omega final minus omega initial over delta t. And that's equal to 28, which is final angular speed, minus 21.5 divided by 6.5 second, okay? And that will be equal to 1 rad per second square. So the first question or the first answer is a correct answer. Okay, so let's move on to the second one. The second, again, is from chapter 1, and it says, find the magnitude of gravitational force. So Fg is unknown, gravitational force. For a person which is 71.2 kilogram with experience while standing on surface of planet Earth. So we have the mass of Earth, and we have radius of Earth, and we have a constant of universal gravitation. So you can just write down the formula or the rule, which is Fg equals capital G, which is universal gravitational constant, mass of the person times mass of Earth divided by r squared. So let's substitute the value. G is 6.67 10 to power negative 11 times mass. The first mass is 71.2, and the second one is mass of Earth, which is 5.98 10 to power 24, which is included in your exam. And then divided by r squared, and r is 6.37 10 to power 6 square. And so to get the result, we have to use a calculator, and the result will be equal to 700.2 Newton, and 700 approximately is in your result. So D is the correct answer for number 2. Okay. So let's move on to question number 3, which is again from chapter 1. And it says how many rad are equal to 35 degree. So we have 35 degree, and we want to convert it into radian. So we have two ways. You can either divide it by 57.3, and that will be equal to 0.61 rad, which is C. Or you can multiply 35 degree by pi over 180 degree, and that will be again equal to 0.61 rad. Okay. So question number 4. The angle between direction of centripetal force and direction of tangential speed is, we already know in a circular path, FC is always directed toward the center. That's why we call centripetal force, okay? And tangential speed is always tangent to the circular path, tangent. So that's tangent, oops. that's tangent. If the rotation, let's say, is clockwise, it doesn't matter if it's clockwise or counterclockwise, still is tangent. So look at the angle between VT and FC. We know that the angle is 90 degree, and that's 90 degree. So D is the correct answer. Okay, so let's move on to the question number 5. Car moves in a circular at constant speed. You have to note that the path is circular and the car is moving with constant speed. So which of the following is true of the motion of the car? It's all about tangential acceleration and centripetal acceleration. You have to know AC is produced due to change in direction, okay? And AT is produced to the change in magnitude. I mean direction and magnitude of tangential velocity. So when direction is changed, AC is produced, and when magnitude is changed, again, AT is produced. Since magnitude is constant speed, so we don't have AT, so AT is equal to 0. But since the path is circular, so we have AC, because in circular motion, always the direction of velocity is changed. So we have AC, but not AT. So look at the answer. The answer is B, because B says it has centripetal acceleration, but not tangential acceleration. So B is the correct answer. Okay, so let's move on to the next one. Again, it's from chapter 1. A car moving around a flat circular track. Identify the force that maintains the circular motion. You have to know which of the following makes or provide enough centripetal force to provide to maintain the car in a circular path. So the first one is the friction between the tire and the road, which is the correct answer because there is a direct contact between the road and the tire. So friction force produces FC. So total weight of the car and normal force doesn't affect or doesn't provide enough FC for the car to maintain on a circular path. Okay, so let's move on to question number 7, which is in chapter 2. Here we have a figure, a clear figure, and 3 forces acting on the object. So the question says, the 3 forces acting on the road have equal magnitude. You have to know that the forces are equal. So we have F1, F2, and F3, and they are equal to 10 Newton, as shown in the figure, okay? And the force produces a greater, so which force produces the greatest torque on the road about the axis? So we have the length as well, and we have the value of force, which is equal in all of them. So let's look at the figure and determine which force produces a greatest torque. You have to know that torque is equal to F d sine theta. So since the force are equal in all of them, so we can't determine which force produce a greater torque by only decided on force. But D is different. So if you look, F1, that's axis of rotation. So F1 is L, which is 1 meter far away from the axis of rotation, while F2 is L over 4. So we already know, and F3 is acted as the axis of rotation. So when any force acts at the axis of rotation, so no torque is produced. So FC is not producing a torque. So the correct answer is between F1 and F2. So the better way is to solve the question in order to determine which force produces a greater torque. So let's find the force or the torque for the first force. So the first torque is F1. F1 is 10 Newton times L. L is equal to 1 meter. And the angle is 30 degrees. So that's sine 30. And that's equal to 5 Newton dot meter. Okay. So let's find the torque for the next one, which is F2. The force is 10 again, but the distance is smaller, which is L over 4, means 1 over 4. Since L is 1, so that's 1 over 4, and the angle is 90, so times sine 90. And the result is 2.5 Newton dot meter. So if you look at the answer, we know that the first force produced a greater torque compared to the second one. So F1 is the correct answer. Okay, in question 8, we have two solid spheres of different diameter and different masses. So M1 is not equal to M2 and diameter of the first ball is not equal to the diameter of the second one. So, but have the same moments of inertia. So the moment of inertia are equal for the ball. So if the diameter of the second sphere, so D2, is half of the diameter of the first one, what will be the mass of the second one compared to the mass of the first one? So let's solve this question. We already know that the moment of inertia of a solid ball is 2 over 5 mr squared, and that's equal to 2.5 mr squared. That's for the second ball and that's for the first ball. We can substitute the value of diameter here, but we can convert it. We can convert the value, since we have a diameter and here we have a radius, so we can convert the value into radius. So let's just substitute the value. So here we have 2 over 5, okay, m1, and that's d over 2 square, and here we have 2 over 5 m2, 1 over 2 d1, and that's all divided by 2 because we convert it into radius. And then here we can cancel out a few of them, like 2 over 5 and 2 over 5 is the same, 2 and 2. So what is left is, here we have m1 d square, and here we have m2 1 over 4d square, and this d again is cancelled out. So m1 will be equal to 1 over 4 m2. What about m2? Because we have to find the mass of the second, and the mass of the second sphere is equals 4 times the mass of the first one. So C is the correct answer. Okay, so let's move on to question number 9. Okay, question number 9. Here we have a solid ball start from rest at the top of the incline, which is 3.5 meter in height. Again, that's in chapter 2. Here we have a solid ball starting from rest at the top of the incline, which is 3.5 meter height. Find the translational speed of the ball after it has rolled to the bottom of the incline. So here we have to find VF. And you have to know that VF for the solid ball is constant, and we can find the value of VF, which is 10 over 7 GHI. You can find the translational speed at the bottom by using this simple formula. So we have everything. So VF is equal to 10 over 7 times 9.81 times, and H is 3.5, and the result is 7.00 a value, and so let's approximate it as 7, and that makes D as a correct answer. Okay, so let's move on to question number 10, and that's again in chapter 2, which is equilibrium. Here we have a man of 720 Newton stand on a light board of length 2 meters. So here we have a light board which is 2 meters long, okay, and a man stands on this board that's fixed on 2 supports at the end. So here we have 2 supports. So we already know when we have a board and a support, we have a reaction force due to the pillars. Okay, so if the distance between the point where the man stands and the first support is 0.5, so let's say that's the first support and that's the second one, okay, so here the man stands 0.5 meter away, so that's the man, okay, 720 Newton, and here is 0.5 meter away from the first support. What is the force exerted by the second one? So here we have to find the second force, which is reaction force, or you can say F2. It doesn't matter, F2 or R2. Let's find this one. First of all, we have to find the axis of rotation, or let's make somewhere on the board as the axis of rotation. We always prefer the heaviest side to be the axis of rotation. So we make here the axis of rotation because we already want to find the second force, not the first one. Okay. So we use the second condition of torque, which says that summation of torque is equal to 0. So we have to know when summation of torque is equal to 0 means that the torque or the clockwise torque, okay, the clockwise torque, summation of the clockwise torque must be equal to the summation of the counterclockwise torque. Okay, so let's find the torque in each side. Here we have two forces, three forces, but two of them produce a torque. R1, it doesn't produce a torque because it passes through the axis of rotation. So two forces is left, 720 and R2. These two forces are produce a torque. So let's find torque for each one of them. So let's find torque for this one. And here we have F2 or R2, it doesn't matter. So how far R2 is away or F2 is away from the axis of rotation is 2 meters. So F2 is 2 meters away from the axis of rotation. What about the second one, which is 720 Newton? 720 Newton is only 0.5 meters away from the axis of rotation. So we can easily find F2, and that's equal to 720 times 0.5 divided by 2, and you will find the result, which is equal to 118 Newton. So A will be the correct answer. Question 11. Ice skater use the principle of conservation of angular momentum to produce high-speed spin. And you have to know that in the conservation of angular momentum, L initial is equal to the L final, or let's say initial angular momentum must be equal to the final angular momentum. So if the skater's moment of inertia decreases to half, so by what factor does the total rotational kinetic energy, change? So we have to know that the rotational kinetic energy is 1/2 I omega squared. So if moment of inertia decreases by half of this value, we already know that angular speed is going to increase. So is it increased by 2 factor or is it increased by 4 factor? Because if it increases by 2 factor, kinetic energy is going to increase by 4. But you have to know that for the ice skater, where the shape of the ice skater is not uniform, and you can change the distribution of mass, you have to know that the kinetic energy is directly proportional to the to omega, not omega square. Kinetic energy is directly proportional with omega square when we have a uniform shape, like a solid ball, like a ring, like a disc, when there is no distribution of mass during the rotation. But for the ice skater, the case is changed, because for ice skater, the distribution of mass is changed during the rotation. You can extend your arm and distribute the mass and change the moment of inertia. So you have to know that the kinetic energy is directly proportional to angular speed, not to square of angular speed. So let's move on to the question. We know that the moment of inertia is decreased by half. So initial angular momentum is equal to final angular momentum, and we know that angular momentum is equals to I omega, let's say for initial, and that's equal to I omega for the final. And you have to know that the moment of inertia is decreased by half the moment of inertia of the first one, And then when you can cancel out this, you see that the omega final is twice the omega initial. And we already know when you lower down your moment of inertia, your angular speed is going to increase because I is inversely proportional to omega. So since the angular speed is increased by 2 times, then kinetic energy also increased by 2 times. So B is the correct answer in the solution. Okay. So let's move on to the next question, which is question number 12. Again, is in chapter 2. We have a force of 12 Newton, which is applied tangentially to a disk of radius 0.2. If angular acceleration of a disk is 4 rad per second square, what is the moment of inertia of the disk? You have to know that when we have angular acceleration and moment of inertia and force, all of these together, you have to use the second law of Newton during the rotation, which is says summation of torque is equal to I alpha. So in this case, I is a noun. Moment of inertia is a noun. So how to find the moment of inertia? And that's equal to torque divided by alpha. But we don't have torque, but we can find the torque by using the rule of torque, which is F times D, and divided by alpha. So the force that acts on the disk is 12 Newton, so 12 times. So tangentially acts on the disk. So that's tangentially 12 Newton acts on the disk of radius 0.2 meter. So we already know that the force acts tangentially on this disk, which is 0.2 meter far away from the center. So 0.2 is the distance that the applied force is far away from the axis of rotation, divided by alpha. And alpha is 4 rad per second square. And the result will be equal to 0.6 kilogram meter square, and that's the first one, which is A, and that will be the correct answer for question number 12. Let's move on to question number 13. Which letter on the graph is used for wave amplitude? You have to know the definition of amplitude. Amplitude is the maximum displacement from the equilibrium position. X-axis is the equilibrium position. So maximum displacement from the equilibrium position is this height. But which letter on the graph use it to provide amplitude? That's D. If you look, that's a maximum displacement. C is wavelengths, and A is crest, and B is crest, and A is trough, and C is lambda. So the correct answer is D, because D is the maximum displacement. Here we have a displacement from the equilibrium position. So D is the correct answer. Okay. So next question, which is question number 14. Okay. In question number 14, we have 2 tuning forks are struck, and the first one produces sound with the frequency of 285 hertz and wavelengths of 1.2 meter, and the second fork produces sound of frequency 570 hertz. So what will be the wavelengths of the sound produced by the second one? So lambda 2 is unknown. But here we have a good note, which says that the 2 sounds are in the air. So when this medium doesn't change, so the speed is constant. So for this frequency, so we can say that frequency for the first tuning fork is equal to the frequency of the next one. So you have 2 choices to solve this question. By having F1 and lambda 1, you can find V1, and then when you have speed of sound and frequency, you can easily find the wavelengths of the second one. But this one again is another solution for this question. So the air, the medium is same, so the speed of sound is the same. So V1 is F1 lambda 1 based on the rule, and that's F2 lambda 2. So lambda 2 is a noun. Okay, and that will be equal to F1 lambda 1 over F2. Okay. So substituting the value, F1 is 285 times 1.2 divided by 570 hertz, and the result will be equal to 0.6 meter, which is the second option, which is B, is the correct answer. Let's move on to question number 15. We have a pendulum bob is made up with a ball filled with water. That's a question from the chapter review. So here we have water. Okay. If the hole in the ball allow water to slowly leak out, which of the following is true? Here, the water is going to leaking out. That means the mass is reduced. The mass of the simple pendulum is reduced. So which of the following is correct? The first one says the frequency pendulum will increase. The frequency does not change. The period does not change. Both B and C are correct. You have to note in simple pendulum, period and frequency are not depend on mass. So period is 2 pi L over AG. So and frequency is 1 over 2 pi AG over L, because we already know that T is inversely proportional to frequency. That's why I rewrite the question for frequency. So since we don't have any change in gravitational acceleration and length of the pendulum, the only change we have in this question is mass. So mass doesn't affect the period and frequency in simple pendulum. So B is correct because the frequency does not change, and C again is correct because the period does not change in simple pendulum. So D, since B and C are correct answer, so we have to choose D because D is included both the answer. Okay, so question number 16. Here we have two waves which have the same wavelengths and amplitude interfere constructively. So if the amplitude of the resultant wave is, so we have the resultant wave amplitude, which is 38 centimeter. What is the amplitude of each wave? What is the amplitude of each wave? Okay. Since the interference is constructive, so you know that the resultant wave is equal to amplitude of the first one plus the amplitude of the second one. So the resultant wave is 38 centimeter, and that's equal to 2a. We know that we add the amplitude when the interference is constructive. So A is equal to 38 divided by 2, and that's equal to 19 centimeter. So that makes B as the correct answer. Okay. So question number 17. Question number 17, we have omega C, which is angular speed times capacitance of the capacitor, which is say equal to which of the following? You have to know that omega C or C is inversely proportional to the capacitance of the capacitor, and angular speed again is capacitive impedance, and you have to know that the angular speed again is inversely proportional to the capacitive impedance. And from the rule, XC is equal to 1 over omega C. So that means omega C is equal to 1 over XC. So B for question number 17 is the correct answer. Question number 18. A simple pendulum is moving with simple harmonic motion. Okay, so here we have this gradient friction and air resistance. So no air resistance and friction effect on the simple pendulum. So which of the following remain constant? That's the main point in the question. For a bob pendulum along the oscillating motion. The first one is the gravitational potential energy. We already know the gravitational potential energy depends on height, and height during an oscillation is changed continuously. So gravitational potential energy remain doesn't remain constant. At maximum point, it is maximum. At equilibrium position, it is 0. Kinetic energy and restoring force is the same, so they are changing during the oscillation. Kinetic energy is 0 at maximum displacement, and it is maximum at equilibrium position. For restoring force, the same. At maximum displacement is maximum, while at equilibrium position is 0. So A, B, and C are not remaining constant during the oscillation. So the correct answer is total mechanical energy, because total mechanical energy during one oscillation is constant in the absence of friction and air resistance. So D is the correct answer. So let's move on to question 19. Okay. Question 19 says, which of the following is true for audible wave, infrasonic wave, and ultrasonic wave in the same medium? So here we have some wavelengths and some frequency which are greater than or less than to each other. So in order to determine the correct answer, you have to know that frequency of ultrasound or ultrasonic is greater than the frequency of the audible, and that one is again greater than the frequency of infrasonic. Because the frequency of infra is less than 20, for audible is between 20 to 20,000 hertz, and frequency of the ultrasonic is above 20,000 hertz. So that makes the frequency of the ultrasonic greater than the frequency of audible and frequency of the infrasonic sounds. Okay, what about the wavelengths? Because we already know the frequency and wavelengths are inversely proportional to each other. So that makes, since the frequency of ultrasonics is greater than those, so the wavelengths of ultrasonic makes less than or smaller than the wavelengths of audible, and that makes the smaller than the wavelengths of infrasonic. So based on these, we can choose the correct answer. The first one says the wavelengths of audible is smaller than the wavelengths of ultrasonic. We already know that the wavelengths of ultrasonic is smaller than the wavelengths of the audible, so the first one is not correct. And number C is not correct again, because it says the wavelengths of these are equal, so that's not true. And B says the frequency of audible is smaller than infrasonic, but we already know the frequency of audible is greater than the frequency of infrasonic. So the last choice is D, and it is the correct answer, because it says the frequency of audible sound, audible, is greater than the frequency of infrasonic. So D is the correct answer. Okay, so let's move on to question number 20. Question number 20 says, a Formula One race car moves with respect to observer. If the observer hears the sound of this engine with 20% reduction, so that's the key to solve the question. So the observer hears a sound of 20% reduction, so here's a lower frequency of its original frequency. So which of the following is correct? So A says the observer and car are at rest with respect to each other. We already know Doppler effect doesn't occur when both observer and source are at stationary. So A is not correct answer. B says the observer is moving toward a car. When an observer moving toward a source, the frequency or the frequency that can be heard by the observer is increases, not decreases. The question says 20% reduction. See the car moving toward the observer. Again, the observer hears a higher frequency than the original frequency. So let's move on to D, and D says the car is moving away from the observer. So when a source is moving away from an observer, we already know that frequency that can be heard by the observer is decreases. So here, since we have 20% reduction of this original frequency, so D will be the correct answer, because the car or the source is moving away from the observer. Okay. So let's move on to the next question, which is question 21. In question 21, we have a figure, and it says which figure indicates the speed of plane attain the speed of sound. So in which of the following the speed of plane equals the speed of sound. We already know when the speed of plane is less than the speed of sound, only disturbance occur in the air, which is number one. In this case, v of the plane is smaller than v of speed of sound. In the second one, as you can see, the shock wave is produced, barrier is produced, which is that's this barrier. This barrier is produced when the speed of the plane attain or equal the speed of sound. So figure number 2 is the correct answer. What about the last one? The last one is occur, which is the shape of the cone, when the speed of the plane is greater than speed of sound, and in this case, the plane is gonna break the sound barrier. So, so in this case, B is the correct answer, which is figure number 2. Okay. Question 22. In question 22, we have a question which says, if the longest wavelengths of a standing wave of a pipe open at both ends, so we have a pipe that's open at both ends, is 4.5 meter longest wavelengths. Okay, that's the longest wavelengths. What will be the longest wavelengths of a pipe that's closed at one end? So we have to find the longest lambda in the next one. We can easily find the solution for this one, and we can calculate it using calculator to find the solution of this question. We already know that the pipe, or the length of the pipe that's closed at one end and the length of the pipe that's open at both ends are equal. And we already know that the fundamental frequency for the pipe closed at one end is V over 4L, while the fundamental frequency of a pipe that's open at both ends is V over 2L. So since L are equal, we can rewrite the question based on wavelengths, because we already know that lambda is V over F. So by substituting a few value, we can get this, which is, say, here we have V lambda 1 over 2, and that's here we have V lambda 2 over 4, okay? And V, let's say, they cancel out, okay? And then, oops, okay, and that's 1 and that's 2. So lambda 2 will be equal to 2 times lambda 1. And that will be equal to 2 times lambda 1 is 4.5, which we wrote before, and that's equal to 9 meter. So since the pipe is closed on one end, and this end is ended with node, and this one is anti-node. So here we have one node and one anti-node. So the longest is twice the wavelengths of the pipe that's open at both ends. So A, in this case, will be the correct answer. Okay, question 23. Here we have a baseball coach shout loudly at an umpire standing 5 meters away. So that's distance, or R. If the sound power produced by the coach is pi 10 to power negative 3 watt, so what is the decibel level? So decibel level means beta, so we have to find beta of the sound when it reached the umpire. Beta, we already know that's equal to 10 log I, which is intensity of the medium, to the threshold of hearing. So threshold of hearing, we already know, is 1 10 to power negative 12, but we don't have intensity. Since we have a power, here is power, and radius, we can easily find the intensity of sound. And intensity of sound is power divided by 4 pi r squared. And power is pi 10 to power negative 3, and that's 4 times 3.14 times 5 squared. And intensity of sound will be equal to 1 10 to power negative 5 watt per meter square. We can substitute the value here in this question. We can easily find the decibel level, and that's 10 log 1 10 to power negative 5 divided by 1 10 to power negative 12, and that will be equal to 10 log. These two are cancelled out, and what's left is 10 to power 7. And 10 to power 7 by using the calculator is equal to 7, and 7 times 10 is equal to 70. So 70 decibel or dB is the correct answer, which is D. So D is the correct answer. Okay, let's move on to question 24. So question 24, we have a figure. In this case, we have to use right-hand rule in order to solve the question, or we have a note for this. Support that Q1, Q2, and Q3, and Q4 each is moving in a circular path in a magnetic field, as in the figure. Which of them is positive charge? Because it doesn't mention that the charge is negative or positive, we have to use our right-hand rule in order to determine which is which. Because we know the figure, we have the direction of velocity, we have the direction of magnetic force, and we have the direction of magnetic field. By using right-hand rule, that's V and that is B, and your palm is for positive charge and this one for the negative charge, you can easily determine which figure is the correct answer. So for this one, A is the correct answer. And remember, when the rotation is clockwise, when the rotation of the object is clockwise, and the field is dot, let's say, or out of the page, that's the rotation is clockwise and the field is out of the page, then the charge is positive. Okay, the charge is positive. As we can see here, Q4 is positive. And when the rotation is counterclockwise, and the field is into the page, okay, again, the charge is positive. So this figure looks like the first one. So Q1 and Q4 are the correct answer. Unfortunately, I can't provide right-hand rule here because I can only write down on the board. I can use my hands in order to solve this problem. But you can use these notes which I wrote below in order to make sure or to find the correct answer. So here we have question 25, and question 25 is from chapter 5, and question number 5, it says an electric current traverse one loop. One loop means N is equal to 1 of circular coil. So you have to know the shape of the coil. And here we have a diameter, which is 50 centimeter, and that's 0.5 meter. Always remember to convert the unit. So calculate the intensity of current. So I is unknown. If the magnitude of the magnetic field at the center of the coil is 4 pi 10 to the power negative 5 Tesla, and we already have the magnetic permeability. Okay, in a circular coil, you already know that magnetic field can be defined by using this formula. That's mu Ni over 2R. 2R means diameter. So you can, because since we have a diameter, you don't have to convert it into radius. Just make this as diameter, because 2R, 2 times radius is equal to diameter. Okay, so intensity of current is unknown. So how to find the intensity of current? By using the cross product. So I is B times D divided by mu over N. Okay. So B in the question is equals to 4 pi 10 to the power negative 5 times D. D is 0.5 and divided by mu, which is magnetic permeability. That's 4 pi again 10 to the power negative 7, and N is 1. So when you calculate it by using a calculator, you can get the results, which is 50 ampere, and 50 ampere makes C as the correct answer. Okay, question 26. In question 26, it says Newton dot second over coulomb meter is equal to which of the following? So the correct answer is Tesla. Why the correct answer is Tesla? We already know that F is equal to BIL. So B is equal to F over IL. The unit of F is Newton, and the unit of I, which is ampere, okay, that's ampere, let's make it simpler, and L is meter. And that's Newton over ampere is coulomb per second times M. So rewrite this equation, and then we will get that the Tesla, which is the unit of magnetic field, is Newton dot second over coulomb dot meter. So A, which is Tesla, is the correct answer for the question 26. Question 27. Here we have a straight segment of wire of length 25 centimeter, and that's 0.25 meter. We have to divide it by 100 in order to convert it to meter, and carry a current of 5 ampere. If the wire is perpendicular to the magnetic field of 0.6 Tesla, what is the magnitude of the magnetic force on this segment of the wire? So magnetic force is produced on the segment of wire when we have an external magnetic field and a length of wire and a current when a current passes through the wire. And that's perpendicularly, that's sine theta. So let's find Fm. So B is 0.6. And you have to know why we can use this formula, because magnetic force is a noun, and we have two rules for magnetic force. The first one is for charges, which is QVB. But this one, we don't have charge, we have current. When you have a current and magnetic field and ask for magnetic field, so remember to use this formula. Okay, so B is 0.6 and L is 0.25 and current is 5, and that's 90 degree, which is equal to 1. So we will find the magnetic force, which is equal to 0.75 Newton. And that makes C as the correct answer. Okay, so let's move on to question 28. Question 28 says, we have some devices, which is motor, transformer, galvanometer, and loudspeaker. So which one of them measure a very low current of order milliampere and microampere? We already know the motor device is converting mechanical energy into electrical energy, into mechanical energy. Transformer is using to step up or step down or increasing or decreasing a potential difference. Galvanometer, which is the correct answer, is used to measure a low order of current between milliampere and microampere. And loudspeaker is converting current to signal. So galvanometer is the correct answer. Okay, so let's move on to question 29. Question 29 says, which of the following equation used to measure a strength of magnetic field due to the direct current in a solenoid? So basically in solenoid, okay, the magnetic field of solenoid is mu Ni over L. If you forget it, you have to know that magnetic field is always directly proportional to the magnetic permeability and number of lengths, number of turn, and current, always. And in solenoid, because we have lengths in solenoid, you have to know that's inversely proportional to L in the case if you forget the rule. Okay, so that makes B as the correct answer. Let's move on to question 30. In question 30, here we have a transformer, we have input potential difference, and we have output potential difference. Okay. So what says in the corresponding figure, calculate the conversion ratio of the transformer. And what type of transformer is this? We already know that the conversion ratio is equal to V2 over V1 and N2 over N1, N2 over N1. Okay, N2 over N1. And how to find N2 over N1? Because we don't have the number of term in the question. So we can find V2 over V1 because we already know that N2 over N1 is equal to V2 over V1. So V2 is 3,600 and V1 is 120. And the result will be equal to 3 over 1. That's ratio. Conversion ratio, that's ratio, 3 over 1. So since N2 is greater than N1 or V2 is greater than V1, so we have to know that the Question number 31. A power station sends power to a city. If the transfer efficiency is 0.95, which means 95%, what is the power sent if power lost in a conducting wire is 50 kilowatt? So we have power sent is unknown, but we have power lost, which is 50 kilowatt, and that means 50 10 to power 3 watt, and we have efficiency, which is 95%. Okay. So how to find the power sent? You already know that the transfer efficiency is equal to power sent minus power lost over power sent times 100, okay? So transfer efficiency is 0.95 and power sent is unknown minus power lost is 50 10 to power 3 divided by power sent. By using cross product, we know that the power sent times 0.95 is equal to power sent minus 50 times 10 to power 3. And that is, we have to a little bit rewrite the question. That's power sent minus 0.95 power sent, and we will make this to the other side. I mean this one, which is 50,000 or 50 10 to power 3. Okay. And that will be equal to 0.05 power. That's equal to 50,000. And power is 50,000 divided by 0.5. And that will be equal to 1 megawatt. And that's equal to 10 to power 6 watt, and 10 to power 6 is 1 megawatt. So 1 megawatt is the correct answer. So that's choice A. Oh, A is the correct answer. Okay, so let's move on to questions. We have Lenz's law. Lenz's law determine which of the following: magnitude of the induced current, magnitude of induced epsilon, direction of the induced current, and all answers are correct. So magnitude of induced current, magnitude of the induced EMF, we can use it by using Faraday, but Lenz's law only determines the direction of the induced current. So C is the correct answer. We can use right-hand rule in order to find the direction of the induced current, as we have it in our book, to find the resistance sometime, and we can use the right-hand rule basically to find the direction. So Lenz's law only determine the direction or determine the direction of current of the induced current inside the coil. Okay, so C is the correct answer. Question 33. Here we have a rule which says epsilon is equal to minus m delta I over delta T. That's mutual inductance. When there is a change in current in a time interval, then electromotive force is induced inside the coil or solenoid. So M in this rule is not a mass, is not a magnetic permeability, is not a constant of universal gravitation. That's the coefficient of mutual inductance. So B is the correct answer. So let's move on to question 34. We have a generator of 40 terrain, an area of 0.3 meters square, is rotating in a uniform magnetic field of strength 0.029 Tesla. The loop's axis of rotation is perpendicular to a uniform magnetic field. So that means the angle is 90 and sine 90 is equal to 1. The maximum EMF is induced, epsilon is 120 volts. So what is the frequency? So we have to find the frequency. We have a rule for generator, which is BA and omega sine theta, but since the rotation is perpendicular, so we have to find the maximum value when the rotation is perpendicular to the uniform field, or the loop is perpendicular to the uniform magnetic field. Sine is 90 degrees. So that's the maximum, how to find the maximum value of EMF. So be careful, frequency is unknown, but here we don't have frequency. But you have to be careful that omega is equal to 2 pi times frequency. So if you find omega in this rule, then you can easily find the frequency and you will get the correct answer. So let's find the angular speed, which is equal to epsilon divided by BAN, where B is magnetic field, A is area, and N is number of terrain. And simply by substituting the value, and B is 0.029 and A is 0.3 times 40, and angular speed will be equal to 349.8 rad per second. And then how to find frequency? We can use this rule. Omega is 2 pi f, and frequency is omega divided by 2 pi, and that will be equal to 349 divided by 2 pi, and the frequency will be equal to 54.88 hertz, but approximately is equal to 55 hertz. So which one is the correct answer? B. So B is the correct answer. Okay, so let's move on to question 35. A generator with a maximum output EMF of 205, that's Vm, which is 205 volt, is connected to 115 ohm of resistance. Calculate the RMS current through the resistor. So I effective is unknown. So how to find the effective value of current? We have to find the maximum value of current. Then we can easily find the RMS value of current. So how to find Im? Based on Ohm's law, Im is equal to Vm divided by R, and that's 205 divided by 115, and the result is 178 ampere, but that's the maximum value of current. So how to find the effective value of current? Effective value of current is equal to Im divided by square root of 2, and that's 1.78 divided by square root of 2, and the result is 1.26 ampere. So 1.26 ampere is B. So B is the correct answer. Okay. Question 36. Okay. That's question 35 and that's question 36. A circuit made up of a resistor, okay, a self-inductor, and a capacitor, okay. All are connected in series, okay. What is the angle of phase difference between current and total potential difference if the circuit is resonate? We already know that the current is, or the phase difference can be found by using this formula when they are in series, okay? And during resonance, we already know that XL is equal to XC. So when XL is equal to XC, then the above of the question will be equal to 0. So that makes theta, let's say tan inverse 0 over R, and that will be equal to 0. So 0 is the correct answer, which is choice C. Okay. 37. 0.75 kilogram mass attached to vertical spring. So we came back to chapter 3, okay? Here we have a mass, and the spring is vertical, it's not horizontal, and a stretch of 0.3. So when a mass is attached, the spring is gonna stretch due to the force of gravity. So the mass is 0.75 and is stretched for 0.3 meter, and that's X. Okay, and you have to be careful. This is downwards. It is minus 0.3 meter. What is the spring constant? So K is unknown. You have to know that restoring force, we have a restoring force in this case, and it's always directed toward the equilibrium position, and restoring force is always equal to Fg, but in opposite direction. You can solve the question in this way as well. And restoring force in mass spring system is equal to Kx. Restoring force is elastic force in mass spring system, so equal minus Kx, and this minus belongs to X. K is always positive, minus Fg, and that's mg. Why Fr is equal to Fg? Because more mass, more gravitational force, and more stretch of the spring, and leads to more restoring force in order to return to the original place or return to the equilibrium position. That's why always restoring force in vertical spring is equal to the gravitational force, but in opposite direction, because both Fr and Fg are in opposite direction. So these minus are cancel out. So Kx will be equal to mg, and K will be equal to mg divided by x. M is 0.75 and G is 9.81 divided by 0.3, and the value of K will be equal to 24.5 Newton per meter, and choice number A will be the correct answer. Question 38. In question 38, here again is chapter 6. Which of the following is not a component of a DC electric generator? You have to know the component of AC generator, DC generator, and motor in order to cover this question, which is the easiest question in chapter 6. So which of the following is not a component? You have to know that's component or not a component. In this case, we have to find the ones that are not component of a DC generator. A magnet. A magnet is a part of a DC generator. Without the magnet, there is no change in the magnetic flux, so there's no electricity. Again, in DC electric generator, we have two brushes, and we have a commutator, since the current is DC. But we don't have two slip ring. Two slip ring is only available in AC generator. So two slip ring is not a component of a DC electric generator. So D is the correct answer. 39. Question 39. Here we have a coil of self-inductance of 50 millihenry is traversed by a current of intensity 2 ampere, and that's the main point or the key point to solve the question, and a direct potential difference, so DC, okay, of 20 volt. What is the self-impedance? We already know that self-impedance is calculated by 2 pi FL. Here we have L, but we don't have frequency. But you have to be careful that XL is directly proportional to frequency. And in DC, since the current is DC, in DC we don't have frequency. So frequency is 0. So when frequency is 0, so the coil is act as a wire. So we don't have a self-impedance, and self-impedance will be equal to 0. So that makes the choice A to be a correct answer. So let's move on to question 40. Question 40, here we have a light fall on two slits spaced 0.33 millimeter. That's D. That's the distance between the slits. Okay. If the angle between the first dark, you have to be careful. We have first dark. For first dark, M is equal to 0. For first dark, M is equal to 0. For second dark, M is equal to 1. For third dark, M is equal to 2. This one is first dark. You have to know that M is equal to 0. That's different from the bright fringe. First bright fringe, M is equal to 1. But for first dark fringe, M is equal to 0. And central maximum, or the angle between first dark and central maximum, is 0.055. So we have to find the wavelengths of light. So lambda is unknown. And remember, we have D, which is 0.33 millimeter. Okay. So we have to convert the distance, which is millimeter, into meter by multiplying by 10 to power negative 3. And we have to write down the rule of dark fringes, which is M plus 1 over 2 lambda, and that's equal to D sine theta. Lambda is unknown, and M is 0. 0 plus 1 over 2 lambda is D sine theta. And lambda will be equal to 2D sine theta by using a cross product, or just multiply both sides by 2. You will get this. Lambda will be equal to 2 times D is 0.33 10 to power negative 3, and the angle is 0.055, and the result will be equal to 6.335 10 to power negative 7 meter. And that makes option C to be the correct answer. Okay. Question 41. We have a double slit experiment, and this one is performed under water. Okay. How would be observed interference of light pattern be affected? Okay, you have to know that the electromagnetic wave is different from the mechanical wave. For mechanical wave, when the medium is changed, when the light moves from air into a water, then the wavelength is gonna increase and velocity or speed of wave is gonna increase. While for light, the case is different. When light goes from air into a denser medium, then the wavelength is gonna decrease. The wavelength of light is gonna decrease, as well as the speed of light, and the angle of diffraction is also gonna decrease. So when the light goes from a low dense to high dense, the wavelength of light is gonna decrease, and the angle of diffraction is gonna decrease, because we already know that D sine theta is equal to M lambda. So based on this formula, sine theta are directly proportional to lambda. So lower wavelengths leads to lower angle of diffraction. So that makes D as the correct answer, because D says theta would decrease because lambda is shorter in water compared to the air. Okay. So 42. Which of the following determine the wavelengths of light produced by laser? The first one says the composition of active medium, B, fully reflected mirror and partially reflected mirror. The fully reflected mirror and partially reflected mirror just use it in laser to make the light more coherent, not determining the wavelengths of light. So the composition of active medium determine the wavelengths of light, and we already know that the active medium can be solid, liquid, or gas based on the laser that I can try to create it. So you have to change the composition of active medium for any laser with specific wavelengths. So A is the correct answer. Question 43. We have another question on chapter 7. If the distance between two lines, diffraction grating is 2 micrometer, calculate the number of lines per centimeter in this diffraction grating. You have to know that D is equal to number of line per unit length. Okay? So here we have to find the number of lines. So number of line per unit length is equal to 1 over D. Okay. And that's 1 over 2 times 10 to power negative 6 meter. So my answer will be in meter. But as you can see that the choices are in centimeter. So we have to convert this meter into centimeter right now or later. But I can convert it into centimeter, which is equal to 10 to power negative 4, or you can convert it later. And then the result or number of line per centimeter will be equal to 5,000 line per centimeter, and that makes A as the correct answer. Okay. Question 44. A light of frequency 110 to power 15 hertz, that's frequency of light, illuminate a sodium surface. The ejected photoelectrons are found to have a maximum kinetic energy, that's maximum kinetic energy, of 1.78 electron volt. And remember, you have to convert it into joule. Then find the threshold frequency of the metal. F naught is unknown. So first of all, we have to convert this one, maximum kinetic energy. How to convert electron volt into joule? We have to multiply the number by 1.6 10 to power negative 19, and that makes the answer of 2.9 10 to power negative 19 joule. So now we have a maximum kinetic energy in joule. Let's write down the formula. Maximum kinetic energy is equals to HF, which is the energy of light, minus work function. Okay? And F naught is unknown. So just rewrite the question. HF naught is equal to HF minus maximum kinetic energy, and divide both sides by Planck constant. And now we just substitute the value. H is 6.63, which is included in the question, 10 to power negative 34 times, that's not F naught, sorry, HF, that's the energy of light, 1 10 to power 15 minus maximum kinetic energy, which we already found, that's 2.9 10 to power negative 19, okay, divided by Planck constant. And the result of threshold frequency will be equal to 5.6 10 to power 14 hertz, 6 and something. Approximately that's equal to 5.7, and C is the correct answer. So question 45, it says, which of the following summarize Rutherford's model of atom? Rutherford. You have to know the model in order to answer this question. The first one says atoms are hard, uniform, and indestructible sphere, or indestructible sphere. That belongs to Newton model. B says electrons are embedded in a sphere of positive charge. That belongs to J.J. Thomson. But C says electrons orbit the nucleus in the same way that planets orbit the sun, and that belongs to Rutherford, which summarizes the model in this way. Okay, so C is the correct answer. Question 46. We have a photon in a lab experiment has an energy of 5 electron volt. Again, the energy is in electron volt. We have to convert it into joule. What is the frequency of this photon? So frequency is unknown. By using this rule, energy is HF. Frequency is equal to E over H, and E is 5 electron volt. Let us convert it into joule, and that's times 1.6 10 to the power negative 19 divided by Planck constant, which is 10 to the power negative 34. And the result will be equal to 1.2 10 to the power 15 hertz. And that is C, in the answer. And C is the correct answer. Okay, question 47. In order to understand this question, you have to know that how transistors work as an amplifier. So transistors are two p-n junction. Okay, that's PNP transistor. That's emitter, and that's base, and that's collector. In order to work properly as an amplifier, an emitter base must be in forward bias. Forward bias. So A is the correct answer. Otherwise, it is not working because we already know we have another battery that's connected between emitter and collector. And in this side is forward and in this side is reverse. If we connect in reverse bias between emitter and base, then the transformer is not working. So it should be in a forward bias. So that's why A is the correct answer. 48. That's the definition of one of the following, which is say an increase in the wavelengths of photon scattered by an electron relative to the wavelengths of the incident photon. And that's the definition of Compton shift. So in the Compton shift, when an photon scattered by a stationary electron, the scattered photon have wavelengths which is greater than the incident one. That's why we choose B as the definition or as a correct answer, which is the statement above in the question is the answer of, or is the definition of Compton shift. 49 is a diode, is a picture of some diodes. We already know the diode is one p-n junction, P and N, P in one side and N on the other side. And in diode, the majority of charge carrier in P-type are positive and majority charge carrier in N-type are negative. And we already know when P and N semiconductor is connected, depletion region is created. And on the depletion region, we have again the charge. The negative charge migrate toward the positive charge. So in the depletion region, in P-type, we have negative charge. That is not correct. We have a negative charge, okay? Oops. Okay, that's negative charge. And on the negative side, here on the depletion region, we have holes because the holes are migrating toward the negative charges. Okay. As we can see from the figure that just I drew it, we already know that B and D are false, are not the correct one, because here we have P-type and the majority charge carrier are negative, but here we have electrons and here we have holes. And again, here in this picture, P, the majority charge carrier are holes. Okay, that's correct. But in depletion region, we have holes near the P-type. So that makes C as very wrong answer. So how to know that A or D, which one is the correct answer? We have to know that the direction of electric field is always from the positive side toward the negative side inside the depletion region. So that's the positive side and that's the negative side. So the direction of the electric field must be in this way. So that makes A as the correct answer. So look at the direction of the electric field. So A will be the correct answer. So let's move on to last question. Which of the following is likely to be able to move and conduct electricity? You have to know that in conductor, because here we have copper atom and here we have a semiconductor and here we have a copper. So in conductor, both valence band and conduction band are merged. So there is no energy gap between them. So any electron in the valence band can contribute electricity and any electron in the conduction band also can contribute in electricity. While for semiconductor, because there is a gap between the valence band and conduction band, so only those electrons which are in the conduction band are contribute in electricity. So based on this information, so let's look on the question and let's see which of the following are correct. So A, an electron in the innermost shell of the copper atom. So in the innermost shell means the electrons are not in the valence band or even conduction band. So they are not contribute electricity because they need more energy in order to jump into the conduction band or into the valence band in order just to conduct electricity. So those electrons are in the valence band of the copper atom, they contribute on electricity. So A is not correct answer. So let's move on to B. And B says a valence electron in the copper atom. The valence electron in the copper atom, they contribute in electricity. So B is the correct answer. But let's move on to C. An electron in the conduction band in the semiconductor, again, they are contribute in electricity. So B and C are correct answers. So that's why we choose D, which is say both B and C are correct. So in conclusion, by addressing all the questions from the first term general examination and providing support to those preparing for the second term, and you have to know that we aim in this that we solve these questions just to enhance you to chance of achieving high mark in the second term. So good luck for everyone and thank you.